YouTube. Presenting tonight is, my name is Joe Deli Carpini. I'm the Science and Operations Officer. I manage the science program for the Boston office. And primarily, it's just a fancy title for the person that does research and training for the staff. And along with me is Bryce Williams, one of our meteorologists. If you've attended our webinars before, you probably know Bryce already. He manages our social media program and also our Skywarn program. So if you attended our Skywarn webinar this spring, you probably heard from Bryce. So the two of us are going to take turns sharing a presentation on Tropical Weather 101. So Bryce, I will let you take it away.
All right, thanks, Joe. We will go ahead and get started. So, as Joe mentioned, it is Hurricane Preparedness Week, and June actually starts our hurricane season, which we'll get into. But it's a great time for us in southern New England to be prepared because most of our hurricanes or in tropical storms that typically impact our area happen later in the season, August, September time period. So now's the time to start learning about it. So start off with the basics. If you've attended our About NWS webinar several weeks ago, we might have learned a little bit about this, but we have, in addition to our weather forecast offices across the country, we have some national centers that focus on specific areas of meteorology, and one of them that most people know about is the National Hurricane Center, and that is down in Miami. It's actually co-located with the Miami Forecast Office, but the Hurricane Center itself, you see there on the left, is dedicated solely to all things tropical. They are developing the forecast. They're coordinating with not only their partners here in the U.S., but also internationally. And they're issuing all the tropical cyclone warnings and forecasts and outlooks that we'll get into later in the presentation. And then how that works with our office here in Norton, they're working together. We are constantly in communication. Whenever there's a threat of a tropical system impacting southern New England, we are in constant communication with the Hurricane Center, and we're providing you all with the current weather forecast and information specific to our area. So we are coordinating with them on what products and warnings to issue and what exactly is going to go into the forecast. So altogether, we hope that gives a uniform idea of what to expect. So back to the basics. So what is a hurricane? To put it as generally as I can, it's a type of tropical cyclone, which is just a broader term that encompasses several different types of storms, and hurricane is one type, one severity. So a tropical cyclone is basically just a storm forming over the warm waters in the tropical area, and it's known because it has a closed counterclockwise circulation in the northern hemisphere, that is. In the southern hemisphere is the other way around, but for us, always counterclockwise. And there are thunderstorms around the center, and also what kind of separates it from storms we see further up north here, usually, it has no association with a frontal boundary. And we'll get a little bit more into that later. And just a fun fact, there's a lot of confusion actually. We get a lot of questions, what's the difference between a hurricane and a typhoon and a tropical cyclone in other parts of the world? And the answer is there's no difference. It's only the nomenclature, the name that certain areas of the world use. So in other parts of the world, hurricanes are known as typhoons, and there's many other different types of names that you'll hear out there. But over here, we know them as hurricanes. So here's a little breakdown of kind of the increasing severity of these tropical cyclones. So what we'll start with is known as a tropical depression. So as soon as we basically get a clustering of thunderstorms out over the tropics that gains some sort of organization, the Hurricane Center will call that a tropical depression. And that is going to be called a depression until the sustained winds reach 39 miles per hour. Once it passes that threshold, it then becomes a tropical storm. That's what we saw with Tropical Storm Faye last week. That had winds between 39 and 74 miles per hour, because once you reach 74 mile per hour threshold, that's when it becomes known as a hurricane. And you can see examples of all these different kinds above it, and you can see the increasing organization just evident in the cloud cover from the satellite. You can tell that on the left it's really disorganized, and on the right it's very organized, very circular, like a buzzsaw, and that means the storm is very strong itself. So what goes into getting a hurricane. So there are four main things that we need. We need, for one, very warm water. Typically, the threshold is about 80 degrees Fahrenheit for the ocean, the sea surface temperatures, this, as we call it, SST, 80 degrees. Once you reach that, you also need some deep tropical moisture in the atmosphere. You need latent heat release, which I'll talk about what exactly that means on the next slide. And then you also need light wind shear. And if you've taken the Severe 101 or Weather 101 classes with us, you'll know what wind shear is. Wind shear is basically a change in wind speed or direction with height. And what with the difference between severe weather, as we think of supercells and tornadoes versus hurricanes, wind shear is good for getting stronger severe storms, but it's bad for getting stronger hurricanes. And that's because when you have greater wind shear, it acts to basically kind of shear or tear the storm apart. And so it can't hold together and it falls apart. So you want to have very little wind shear for a strong hurricane. So what basically happens is, step by step, you have warm, moist air moving over the ocean. And as we talked about previously in our cloud formation topic, the water vapor rises in the atmosphere, and as it does, the air cools, and when it cools, it condenses into liquid droplets, and that forms the cloud. Now, when this happens, something that's known as the latent heat of condensation is released. And basically that is heat energy that is released out into the atmosphere. And this makes the air lighter, and then that warmed air then continues to rise with the moist air from the ocean, taking the place and creating more wind. And so it's just this endless cycle of latent heat release and rising and condensing air that is feeding the hurricane itself. And you can see these pictures of some very strong, very well-developed hurricanes with very evident eyes. And we'll talk about what those eyes are here, I believe, next or soon. Yeah, here we are. So the structure of a hurricane, you probably are at least somewhat familiar with the generalities, say maybe the eye, maybe you've heard of the eye wall. But this is a kind of a diagram showing basically if you cut a hurricane in half, a textbook, well-organized hurricane, this would be very strong. This is what it would look like. And so, the most tracked and talked about part of the storm is right there in the center. That's the eye. The eye is the cloud-free, generally mostly cloud-free area in the very center of the storm. And why that is because you see these circular bands that surround the storm. They have rising air that's rising up as it warms, just like we just talked about. And in the center, what's known as the eye wall, that's where typically the most violent winds, the strongest thunderstorms, the most intense part of the storm is in that eye wall. And so as those storms those updrafts are very strong, they're rising very, very violently, and then the air, that warm air, hits the tropopause and it spreads out, and some of it is expelled. You see the big blue arrows. It's expelled out into this dense cirrus overcast, basically layer of cloud high above the storm. But then some of it is sent down through the middle of the storm, and it sinks. And it's known as subsidence, and it's subsidence, and what that's doing is warming the air, and so it's drying it out, and so you get the cloudless center. And in that center, if you were to experience a hurricane, you would basically a sequence of the very strongest winds followed by nothing or close to nothing. It would be very calm. Sometimes you can see the sun and the blue sky comes out, and then it keeps moving, and you hit the other eye wall with strong winds again. Now, outside of the eye wall, you also have these outer rain bands. And so these are basically just spiral rain bands that contain thunderstorms. Oftentimes they'll spawn tornadoes, that kind of thing. And those can be dangerous as well. They're just not quite as strong as the eye wall. All right, so I mentioned hurricane season starts in June, and it goes from June through the end of November. But you can see here, this graph, the number of storms per 100 years, that the peak is well into the season, actually in September. So June, July, we really don't often have that many hurricanes. And you can see the stat there, 2/3 of hurricanes actually form after August 28th. So a lot of it is between late August and early October. Now, a lot of the questions that I've gotten before from people is who gives the name, and how do they choose the name, and when was that decided upon? And so it's interesting, actually. Before 1950, they weren't named. So the Hurricane Center started formally naming them in 1950, and originally they were named just on a phonetic, and they were just started a general phonetic alphabet. You can see the example there: A name, B name, C name. And then just 3 years later, in 1953, they actually changed in favor of using alphabetized female names only. It wasn't until 1978 that male names were added, and basically that's the system we use today, and it alternates between male and female. So you can see the 2020 list that we're going through right now, checking off. We just, when I originally made this list, I hadn't checked off Faye, but we actually just had that check that off because we had Tropical Storm Faye. So we're making our way down the list. Hopefully, we won't have to go all the way to the bottom this year. We'll see how it plays out. But you can see we already have names lined up all the way at least 2024, and I believe beyond, if we just have those listed as an example. Okay, so hurricanes are rated on what's known as the Saffir-Simpson scale. It's different than than the EF enhanced Fujita scale that we use for tornadoes. This is based solely on a hurricane's sustained wind speed. And in addition, the scale does estimate potential for damage, but the number actually comes just from the speed. And so you have what we talked about before. The first category is tropical depression, less than 39 miles per hour. Then you move on to a tropical storm to 73 miles an hour. Category 1 is reached at 74 miles an hour. Category 2 up to 95. Category 3, 111. Category 4, 130. And then anything over 157 miles per hour is a Category 5. And those are the most intense and most devastating hurricanes. And actually, anything that ranks Category 3 or above is actually considered a major hurricane. So major hurricane is Category 3, 4, and 5. And so you can see here them broken down by category and just the description of the damage that they're expected to cause. You see from tropical storm causing some damage up to a Category 5 causing catastrophic damage. And so you'll see examples of exactly what that looks like later on in this presentation. It will show you what it looks like on one house from one category to the next. So a couple of more terms that you might hear thrown around during hurricane season if you're watching the Weather Channel or you're looking at our discussions with the Hurricane Center. And one is called an invest. That is basically just it's the beginnings of a system. So it's just a weather system that the Hurricane Center is monitoring to see if it's going to show signs of tropical development. So I believe Tropical Storm Faye was Invest 98L, what they called it, until they knew that it was going to get strong enough to become tropical storm, and then they named it. Also, another thing that you might hear, a term you might hear, is a potential tropical cyclone. Basically, that's just a tropical system that isn't yet a depression or storm, but is expected to bring tropical storm or hurricane conditions to somewhere to land within the next 48 hours. So it has the potential to become a tropical cyclone, but it hasn't quite gotten all those characteristics yet. So they can still give people a heads up. And then we already talked about what a major hurricane is, Category 3, 4, and 5. Oh, and just something to point out on that last slide, the picture is one of the planes the Hurricane Center actually flies into. They fly through these Invest, tropical storms, and hurricanes. They're known as the hurricane hunters, and they send back live data. So that's a really cool thing that they do in combo with the Air Force. So one thing we like to emphasize here in Southern New England, and people say, we can't get hurricanes up here. And we say, yes, yeah, we actually can, and we have, and we will in the future. We like to say a general rule of thumb is anything that has a name in the Bahamas is New England's business. So that's when you need to really start paying attention, because if it's in the Bahamas and it's already a named system, then history tells us that there's really good odds that is going to move up the East Coast and potentially impact us. All right, so a little bit about climatology and where storms form based on the time of the year. Just real quick, we'll run through these. So in June, really early in the season, you see there's a lot of, well, a lot, I say a lot in quotes, because really on average, it's only about one storm every other year. So June is pretty rare for actual named storm formation. But when they do happen, they generally form in the Northwest Caribbean Sea or over the Gulf of Mexico. Then move on to July, it expands a little bit, spreads east to cover the Western Atlantic, the Caribbean, and the Gulf of Mexico. So all three of these are likely, but you see still there's none that say more or most likely, still just kind of likely. Now August, we really start to get into the peak, towards the peak of the season, and really pretty much anywhere in the whole basin, and we average generally about 2 to 3 storms each year, and you can see the bullseye of where the most storms are likely to form. And then we get to our peak, like I said before, September, climatological peak of the season, and storms can form nearly anywhere. So, it's your guess is as good as ours until we start to see some sort of clouds start to organize. Once we get to October, it starts to then shift back towards the west, to the Gulf, the Caribbean, and the Western Atlantic. And then in November, it's pretty rare. It's same kind of like June, about one storm every other year or so, and they generally go out to sea. And one thing that one question people have when we because actually this year and several years in the past, we've gotten a storm that's formed even before the season starts, so in May. And people will say, is there does that correlate with a stronger? Does that mean we're going to have a stronger hurricane season or a weaker? And really, the studies that have been done show that there is no correlation with what date, how early we have our first named storm, and how active that season is later on. It's really just pretty random, and so there's nothing that we can really glean from. Oh, we got a storm in May. That doesn't really tell us about the severity or intensity of the season to follow. And with that, I will pass it over to Joe for the next section.
Okay, thanks, Bryce. So our next section, we're going to talk a little bit more about New England hurricanes and use some of the historical storms that many of you may remember to kind of get some of our points across. So certainly the Great New England Hurricane of 1938 is kind of the benchmark of all New England hurricanes. You can see these two newspaper headlines. Essentially, hundreds homeless, Harbor View wiped out, Misquamicut Point gone. 50 dead, scores missing. That obviously caused tremendous damage. And as you'll see, we are long overdue for another hurricane. Maybe not to the level of 1938, but maybe. But even just a Category 1 hurricane could cause quite a bit of damage. So talking of some of our, let's say, our recent, and I put that in quotes, hurricane landfalls, certainly Bob in 1991. Many of you probably remember that one. Going back a little more, Gloria in 1985 was another one. Actually crossed into Long Island. And then we also have Bell, and going back a little further, Donna, which caused quite a bit of damage. And then Carol and Edna in 1954 were both pretty significant hurricanes for southern New England. And again, some of you may remember that. But the hurricane return period, so what you may have heard this term, what does this mean? Well, on average, and these are the kind of the years up along the coast, a hurricane will track within 50 miles from southern New England, so that includes Connecticut, Rhode Island, or Massachusetts, about once every 13 to 18 years. So our last landfalling hurricane, as I mentioned, was Bob back in August of 1991. So that's a little more than 13 to 18 years, for getting a hurricane strike here in southern New England. And while some of you, may remember Bob, and it caused quite a bit of damage on the south coast, and especially Martha's Vineyard and on parts of Cape Cod, many people who now live in the area and specifically along the coast have never experienced a landfalling hurricane, or maybe even a tropical storm. So that's if it's not in people's memory, they may not know how to respond when we actually have a real threat. Now, when we talk about major hurricane return periods, what does that mean? Well, that means on average, a major hurricane will track near southern New England every 50 to 70 years. So our last major landfalling hurricane was Carol in 1954. So again, we're getting in that period of where we're getting due on average to see a major landfalling hurricane here in southern New England, and something that really hasn't been experienced in generations. So if we were to have a major hurricane strike here, our fear, from our standpoint of trying to protect lives and property, is that people won't take the message seriously, and there'll be quite a bit of not just damage, but potentially loss of life, simply because people just won't take the proper precautions. So let's talk a little bit about our New England hurricanes, some of the common characteristics. Now, every storm undergoes a transition from being pure tropical, and that's that buzzsaw pattern you see on the satellite image, to what's called extratropical. And what do we mean? What is extratropical? Well, that's like a winter storm or a nor'easter upon its approach to New England. So what it does is, when it's tropical, it has what's called a warm core. Essentially its core is full of warm air, unlike when we have a nor'easter or a winter storm. That's called a cold core system. So when storms get to this latitude, they interact with the jet stream, and that causes them to undergo that transition to becoming more of a winter storm-like system. So there's a rapid acceleration up the coast. The heaviest rainfall usually is focused along and west of the storm track. That happens almost with every single storm, and it even happened with Faye, and we'll show you that a little bit in a minute. The high winds are focused east of the track. So if you know which way the storm is tracking, the heavy rainfall is to the west, the storm surge and the high winds here are to the east. And that just makes sense based on the storm circulation, but I'll show some examples of that. And for the storm surge being focused east of the track, the greatest surge depths will occur on the upper reaches of south-facing bays and inlets. So what does that mean? Well, if a hurricane is tracking northward and goes across eastern Long Island and into eastern Connecticut, you're going to have the strongest winds on the east side, which may be up Narragansett Bay and Buzzards Bay. So those communities near Narragansett Bay, and especially Buzzards Bay, will see those highest depths of storm surge. And that's something that hasn't been experienced in generations here in southern New England and can really catch people off guard. So we'll detail these hazards a little bit more in the next few slides. So the rapid acceleration northward, a study of past New England hurricanes shows the average forward motion for storms impacting New England is 33 miles an hour. That's a lot faster than the storms moving 10 to 15 miles per hour down in the tropics. Now, the Great New England Hurricane in 1938, it made the trip from Cape Hatteras to Providence in only 8 hours. Its forward speed at landfall was 51 miles per hour and estimated as high as 60 miles per hour. And you can see here on the right some of the more memorable hurricanes we've had here in southern New England, looking at their forward speeds. Yes, some of them, like Diane, were moving slowly, but others, like Gloria, were moving a little bit quicker, or Edna, 45, 46 miles per hour. So on average, it's 33 miles an hour. And the typical thing we say is it's in around breakfast and out by lunch or dinner time. They move very, very quickly, these storms. So that's why we say anything in the Bahamas is our business, because we often don't have a lot of time to prepare once a storm is formed in the Bahamas. It gets caught up by the jet stream and rapidly moves along the coast and gets here in a matter of hours. So now we'll detail some of the hazards here briefly, talking about storm surge, damaging wind, tornadoes, and inland flooding. So storm surge is actually the main hazard from hurricanes. It's not the wind. Almost 50% of deaths are due to storm surge, and most of the Atlantic and the Gulf Coast population lies at elevations less than 10 feet of mean sea level. That includes here in New England. And our coastal population, as I've mentioned, the density increases every year. We also have large seasonal populations here in the summertime, Cape Cod, the islands, even along the coasts of eastern Massachusetts and the south coast of Rhode Island. It's vacation time, so these seasonal populations swell, and people that aren't familiar with the area necessarily too. So storm surge, again, is the primary hazard with hurricanes. So some of the things that influence how much surge we will see is, of course, the wind, the speed and direction. The angle of approach to the shoreline. Is the storm making a direct hit, or is it moving more parallel? Its forward speed and storm size. That's how much water or surge it can generate. Also, its central pressure. Like a nor'easter, the deeper the storm, the stronger the storm, the more surge it can produce. Also, things like the bathymetry, the continental shelf we have here in New England, the width and the slope, how that surge is going to behave, and also the shape of the coastline. So those are all things that we take into account when we're coming up with our forecast of storm surge for a particular hurricane, or even a nor'easter. This also applies to that. So when I talk about the angle of approach and the wind speed and forward motion, typically the south coast sees less surge but greater wave damage, just because it's got to do mostly with that angle of approach, but also with the bathymetry. And then when we talk about the upper bays and tidal rivers, that could be Narragansett Bay, Buzzards Bay, and also the rivers that drain into them, they will see greater surge due to funneling, but obviously less wave damage because you're removed from the coastline. So here's an example of two angles of approach. You have Carroll and 54 up through Connecticut. Your highest surge was in essentially Narragansett Bay. Well, as Hurricane Bob took a little more of a, I wouldn't say perpendicular or parallel, maybe about a 45-degree angle to the coast, and brought its greater surge and wind to Cape Cod and the islands. So again, these are two things that we take into account. Now, we do have things today, storm surge maps, that actually can show us ahead of time what areas would be inundated for a particular category of storm. So this is a kind of a worst case scenario, category 4 storm surge map, which shows inundation all across the upper end of Buzzards Bay and actually both sides of the Cape. So we use these kind of as references for the depth of the water based upon a particular category of storm as well as its direction and speed of motion. So we'll use these as references. And these are also available online. So when we talk about surge, this was Oakland Beach and Warwick back in the 50s. You have two things. You have two debris lines in that case. Homes were destroyed and dislodged from the surge itself. And then you had another line of debris, which was initiated here, which was from properties being pushed into the properties here. So it wasn't just pure surge like we had surge damage here, but actually debris that caused additional damage further inland. And more recently, Sandy in 2012 brought a significant amount of storm surge and erosion to Rhode Island. This is an example from Sandy. Again, we had persistent surge and wave action. I believe this was over in the westerly area. But look at the depth of the sand that was piled up. This is a door. It's almost up to the height of the door. It was up to the height of mailboxes. So we had days and days of pounding surf and erosion and storm surge. So it can result in quite a bit of damage and also piling up of sand. So now when we talk about damaging wind, obviously we're talking about damage to buildings, structures, power outages. And you can see here on the right this image of, this is a nighttime image showing areas without power. You can see in the middle where the wind damage occurred, where there's no light whatsoever. So going through what Bryce talked about, our hurricane intensity scale, I'll go through these quickly, but this shows you kind of the differences between category 1 and category 5. So when we get to category 1, you see some minor damage to roofs, maybe some minor tree damage, shingles can be peeled off. Maybe some damage to weakened, more weak structures. As we get to category 2, there's more substantial damage to the roof. It's not destroyed, but there's more damage certainly to trees, especially the trees in our area, maple trees, oak trees, pine trees at that point. As we get to category 3, the damage increases. Now we're seeing damage to the roof of the structure, damage to trees, and certainly when we get up to category 4, it gets multiplied even higher. And category 5, pretty much it's wiping the houses off the foundations that are affected by the wind. So just to show you a quick kind of example of the difference between category 1 to category 5. There we go, category 5 right there. So for high winds here in southern New England, the radius of high winds, talking about the area that's covered by them, varies considerably. This is not a widespread phenomenon like you would see down in Florida or the Gulf of Mexico. Hurricane Bob in 91, the highest winds were only 25 miles in radius, fairly narrow area, as you can see kind of here on this map in the red shading. Whereas the 1938 hurricane was about twice that, 50 miles. And again, the high winds are focused east of the track, and it's enhanced by its acceleration toward New England. So on the east side, it's kind of like you're adding the forward motion onto the maximum wind, and that adds to your gust potential. So with the 1938 hurricane at the Blue Hill Observatory, they recorded a sustained wind of 121 miles per hour and a peak gust to 186 miles per hour. Whereas on the western side of the storm, you actually subtract the storm motion from the maximum wind. So the winds are relatively weaker than they are on the east side. And the one thing to keep in mind is we really need to keep in mind the wind direction. So our trees are not weathered here for strong winds out of the southeast. Our trees are weathered for winds out of the northeast or the east or even the northwest. So remember Irene in 2011, there was quite a bit of wind damage from what was just a tropical storm, primarily in Rhode Island and eastern Massachusetts. Some communities were without power for 2 to 3 weeks, and there was tremendous amounts of tree damage. So that was all because of the wind direction. Had the winds come from another direction, maybe the east or northeast, we wouldn't have seen anywhere near the damage that we did. So that's something to keep in mind as well. And as far as the behavior of the wind field, it's relatively short duration of tropical storm force and hurricane winds. Typically about 12 hours of tropical storm force winds and only 3 to 6 hours of hurricane force winds. And that's because the storm is accelerating as it moves through the region. For you trivia buffs, some notable wind speeds: Hurricane Carol at TF Green Airport near Providence had a 90-mile-an-hour sustained wind with a peak gust of 105 miles an hour. Hurricane Donna in 1960, a peak wind gust of 130 miles per hour on Block Island. It caused a considerable amount of damage. Hurricane Bob, again, 1991, peak wind gusts of 120 to 125 miles per hour on Cape Cod. And there's a couple of the damage photos. And the thing we always say is, what are these people doing near the wires? Always, always, always stay away from down wires after the storm. Now, tropical tornadoes are a little bit less common here, but they do occur. In all, 60% of landfalling hurricanes produce tornadoes, but only 25% are actually close to the center, and that means within about 125 miles, as you can see here in the red shadings. Most of the tornadoes occur in the outer rain bands of the storm, and typically on the east side, especially the northeast side of the storm. So if we know the storm is tracking, say, into Connecticut or Rhode Island, our tornado threat might be on Cape Cod or southeast Massachusetts. Or if the storm tracks, say, into western Connecticut, we would know the tornado threat might be more across Long Island and eastern Connecticut or Rhode Island, depending on the distance. But it's this northeast part of the storm, away from the center, in those outer bands, where tropical tornadoes are favored. Now, when we get into heavy rain, this is one of the main hazards here for us. And the heaviest rain, as I mentioned, usually falls along and west of the track. So nearly half of all the storms that have affected the region have produced small stream or river flooding, even when there's been drought conditions. Some of you may remember Hurricane or Tropical Storm Floyd back in 1999. We were in a drought prior to Floyd, and it ended up producing significant flooding here in southern New England. On average, the rainfall tends to go about 6 to 8 inches. But we can have blockbuster rains when we have slower moving storms, like Diane in 1955 dumped 15 to 20 inches in parts of western Massachusetts. And I believe the state record in Massachusetts for rainfall over 24 hours is in Westfield. It was just over 18 inches. And Irene in 2011 dumped 10 to 16 inches of rain in western Massachusetts. So again, on average, typically 6 to 8 inches. It can be less if the storm is moving faster, or if we're on the east side, certainly. But again, there's potential for these excessive, highly excessive rainfall amounts that can result in disastrous flooding. So Irene in 2011, some of you may remember that. The track was up through New Jersey and into southeast New York and into northern New England. And look at where the heaviest rainfall was, along and west of the track. We had very little here in southern New England. That was also the theme with Faye, which I'll show in a minute. But if we look at places in eastern New York, this is Prattsville, west of Albany, or in Conway here. Massive, disastrous flooding from over a foot of rain that fell in a very short period of time. Now here's Faye, the track just last week. Again, fairly similar to Irene, up through southern New Jersey and into close to Albany. And notice where the heaviest rain fell, in excess of 4 to 5 inches in parts of southern New Jersey. Very little rain here in southern New England on the east side of the track. And you know, the reason why our forecast rainfall was overdone a couple of days in advance was simply because the track from the National Hurricane Center at that time, which wasn't bad for a couple of days out, remember, there can be pretty large errors at 48 hours out, was actually through southern Connecticut, through Long Island and southern Connecticut here. And at that point, there was still quite a bit of uncertainty. Was the storm going to track west? Some of the models had it in Pennsylvania. Was it going to track east? Some of the models had it actually south of Nantucket. So based upon that uncertainty and a most likely track through Connecticut, we decided to hoist the flash flood watches for much of our area, knowing that a track over here was certainly possible, and that would have shifted all of this rain further east into New England. Now, the next night or the next day, when that became apparent that the track was going to be west, the flash flood watches were actually dropped, but were kind of maintained here again, still, because there's that uncertainty in the track. Again, a track a little bit farther east would have brought this rain likewise a little bit farther east. So that's in a nutshell why the rainfall forecast was overdone so much. So again, to stress, heaviest rainfall tends to be along and west of the track here in southern New England. So Bryce, I believe this is your section, correct?
Yes.
Okay, so I will give it to you.
All right. Thanks, Joe. So now we're going to shift gears a little bit into understanding the information that you may see come out of our office and the National Hurricane Center when there is a tropical storm or hurricane threatening. So we'll start with the most basic, which is the tropical weather outlook, and the Hurricane Center puts out 2-day outlooks and 5-day outlooks, and they are pretty graphically easy to understand because they're color coded, yellow, orange, and red, and the color changes by increasing potential of storm formation. And so you can see, yellow, there's a lower chance. Red, it's higher than 50% chance that there's going to be a named storm forming. Now, this is the all famous hurricane cone forecast, which you've probably seen and heard about. And there's a lot of misconceptions about what exactly it means, but it's really pretty simple. Basically, it's just indicating the probable track of the system. The black dots do not indicate exactly where they think that the eye is going to be. The cone indicates the probable track. Anywhere in that cone is where they think that the track of the storm is going to be, and really 1/3 of the time the track actually occurs outside of that cone. Another thing that people get confused about is this cone is not an indication of where you will see impacts from this storm. So you don't want to say, oh well, I'm outside the cone, so I'm okay. You actually see, look, you see that they have these blue outlines for a tropical storm warning outside of the cone. That's because just because the center of the storm doesn't go over your area. Hurricanes are very large, expansive storms, and they will have far-reaching effects. So don't think that just because you're not in the cone means you're in the clear, because that's definitely not the case. Another kind of popular, relatively new graphic is these colorful ones that indicate wind speed probability. And so you'll have these. You can see the legend at the bottom, the probability of tropical storm wind speeds. And you can also see this example is actually not only that showing the probability of tropical storm wind speed, but also the arrival time. And there are 2 different arrival time graphics. So it can be, you got to make sure that you're looking at the title of the chart that you're looking at. So this example is the earliest reasonable arrival time of the tropical storm force winds. They also have the most likely arrival time of the tropical storm force winds. So that would be their forecast. Earliest reasonable is just to give you an idea of, say, if the forecast hedges on either end, this is the earliest that we think that it could, but it probably most likely is going to happen at this time in this other graph. So be attentive to the titles of the chart you're looking at, because they look similar. And as we progress through the life of the storm, we will often issue watches and warnings, whether it's hurricane or tropical storm. So we'll have a hurricane watch or warning, or a tropical storm watch, tropical storm warning. The watches are issued 48 hours in advance, and the warnings are issued 36 hours in advance. And I'll get into a little bit about what these actually mean in the next slide. So there is some confusion as to what a watch really, hurricane or tropical storm watch really means. A lot of people, at least if you're pretty in tune to the weather, which a lot of you guys watching this webinar may be, they understand what a severe thunderstorm or a tornado watch and warning is. And so this is an example. Tornado watch basically identifies the area where conditions are favorable for severe thunderstorms and tornadoes. So the area that severe weather is possible. Now, with a hurricane watch, what this means is that hurricane force winds are possible somewhere within the watch area, and the emphasis is on somewhere within that watch area. So basically, we and us with the Hurricane Center, we're intentionally spreading our warning net wider, casting a wider net, because of the uncertainty as to where the maximum winds are going to be. So not everyone in this hurricane warning is going to have tropical storm or hurricane conditions. So if you take something away from this slide, that's it. Just because you're in, the warning box or in the warning shaded area doesn't mean you will certainly get the conditions. They are basically painted wider because of the inherent uncertainty as to where the maximum wind speeds are going to be. Same thing with
and Bryce,
warnings.
and just to follow up
Yeah.
on that, let's use Hurricane Bob. There actually were warnings up along the entire coast of Rhode Island, I believe, up through Plymouth County in Mass. But where did the hurricane force winds end up? It was just a small section of the south coast and Martha's Vineyard and Cape Cod. So again, it's not an overwarn, but it's making the warning area larger because somewhere in that area is going to receive those maximum winds, not everywhere.
Yes, and it's better for people to be prepared and to not have to actually deal with those conditions than to not prepare and then you get those conditions by surprise. Same with the warning. Same idea with the warning as the watch. Basically, tornado warning identifies area within the tornado watch is expected to occur somewhere within the polygon, and a hurricane warning means hurricane force winds are expected somewhere within the warning area. So unlike the watch, this warning means somewhere within this area, within 36 hours, we do actually expect, not just possible, we expect somewhere in this area to get the hurricane or tropical storm force winds. Now, in addition to the wind-related headlines or watches and warnings, we also have storm surge watches and warnings. And so a storm surge, like Joe talked about, that surge of water coming into the coast, the storm surge watch is issued when there's a possibility of life-threatening inundation from that rising water moving inland, generally within 48 hours, as opposed to the warning, which is the next step up. That is when we do expect the danger of life-threatening inundation within the next 36 hours. And if these are issued, we ask that everyone, follow the evacuation orders and instructions from your local officials.
And Bryce, just to mention what is life-threatening inundation, it's typically defined as 3 feet of water depth. So 3 feet of water above the ground is typically the threshold that's used for the life-threatening inundation.
Perfect. Okay, so if you're looking for information on any, you're wondering, oh, I wonder if there's any tropical systems headed our way or out there in the Atlantic, you can go to our website, weather.gov/Boston, and either finish that URL/tropical, or you can just scroll down to the bottom of our homepage and look for the hurricane icon. It says tropical. It'll take you right to our tropical webpage, and it's got everything there that you would want to know. The outlooks, any active storms, threats, and impacts, any products that are out, satellite radar, all sorts of stuff you can find there. It's all your one-stop shop for tropical info for Southern New England. All right, so real quick switch to kind of more of a preparedness idea. So a couple of things that we need to ask ourselves as we are preparing for a potential for a tropical system. Can we stand on our own feet for 48 to 72 hours after a major hurricane strike? You have to think about that, because if you're hit by a major hurricane, your house could potentially not be livable. You may be displaced from your home for a long period of time. So we need to make sure that we are ready to be self-sustaining for a certain period of time. Keep in mind, say we have a tornado move through, or a storm with straight line winds. You're calling emergency services to help you out. That's just kind of a localized event. With something like this, you're not going to be the only one requesting help. There's going to be a whole, half a state or a state full of people that are also needing help. So you're not going to be the only one requesting help. So you need to be prepared to kind of be self-sufficient for a while. Pre-planning makes it less stressful. Another thing we can ask ourselves, are we ready to deal with widespread and long duration of power loss, utility loss? It could be out for weeks. Just some examples that we put in here. Gloria in 1985 was only category 1, lowest hurricane we have, and it left parts of the area without power for over 2 weeks. And much more recently, in more recent memory, 2011 Irene was just a tropical storm, and certain locations had power out for up to 2 weeks. So think about that when you're planning this disaster kit, this disaster plan. And also, loss of phone communication. Carol back in '94, took all of Rhode Island's phone lines down. And yes, now we're not as reliant on landlines, but also cell towers can be taken down. You can still lose phone service nowadays. Another question, are we ready to deal with widespread structural damage to property along the immediate coastline? Debris removal, getting access into these areas, because you think about these roads, they're lined with trees, they've got power lines, all these things that can come down and make it very difficult to get in or out. Contamination from fuels and natural gas lines, ripped up septic systems. So this water that may be flooded on your street, in your house, people think, oh, it's flooded, I'm going to go play around in it. But you got to think about what else is in it. It's not just ocean water. It's all this other nasty stuff. Transportation, how are you going to get supplies and food and water in? So you want to have a supply of water to last you for several days at least, food, stuff like that. So with all that in mind, we ask that people make a hurricane plan for you or your family. Where can you get ideas as to what to have in that plan, how to make that? Again, go to our website, weather.gov /Boston, and up at the top you'll see a safety tab, and then you can scroll down and click hurricanes. That'll take you to weather.gov /safety/hurricane, or you can navigate there directly, and that will have all the information that you could possibly need or want about having a hurricane plan to make sure that you and your family are prepared in the event that for if and when southern New England is impacted by a tropical storm in the future, because it's going to happen. The question is just when, and it's better to be safe than sorry, better to be prepared to have it and not need it than need it and not have it. And I think that is the end. Yeah, that's the end of our presentation. So thank you guys for listening. Hope you learned something. And I think we're going to take some questions now, Joe, right?
Yeah. Okay. Well, thanks, Bryce. And again, the key point we want to stress is just be prepared. We're not saying there's going to be a hurricane tomorrow, next week. Maybe we won't have one this summer here in southern New England. We don't know. But the odds, favor having a tropical storm or hurricane landfall here in southern New England, based upon what we showed, kind of the average, number of years. So be prepared. And it's not just for people on the coast or whether you own a boat, even people inland. Remember, inland flooding, inland wind damage. It's always a good idea to have a hurricane preparation plan. So we'd like to stress that tonight. So let's go to some questions. We're gonna answer as many. We're gonna answer them all. So feel free to stick with us. So first question is actually just about the webinars. Is there an email list to be notified when new webinars are coming out? No, Brian, that's from Brian. We don't, but we do keep our webinar listing on our webpage, and we do have a headline up at the top where you can bookmark it. So we also use social media, Twitter, Facebook. You'll also see posts on there. So we advertise them as much as we can. There's just unfortunately not an easy way to make an email list. I'd love to be able to do that. I know we have a lot of repeat visitors to our webinars and fans. So let's see. Question from Jiban. What is the major difference between hurricanes and winter storms such as nor'easters? I can answer that one, Bryce, because I kind of talked about it. Again, a hurricane is a warm core system. So what does that mean? It's got warm air through its center. If those of you who are around for Irene, remember when Irene came to pay a visit, it was warm actually through the whole storm. It never really got cold, even at night. We had a tropical feel to the air. It was very humid, very sultry. Whereas a winter storm is a cold core system. Its energy is from temperature differences, usually Arctic air and warmer air over the ocean of the Gulf Stream. So it's a cold core system. There's cold air at the center. So they're almost exact opposites. That's really kind of the major difference between the two. And again, as I mentioned, hurricanes and tropical storms are kind of turning into these winter storms, nor'easter type systems. They're losing their tropical characteristics, losing their warm core, and usually becoming more of a cold core system as they approach us. Let's see. Kevin has a question. Says it's very informative. Thanks, Kevin. Burning question I've had for several years now: is southern New England overdue for a landfalling hurricane?
Yes.
Bob. Let's see. Yes, can it be overdue? Absolutely. And I think we kind of mentioned that during the presentation. We are more than overdue. And that's something that we, kind of is in the back of our minds every hurricane season for us who work at the office, because we know there's, again, a generation of people who live on the coast who have never experienced one. and probably won't take the necessary precautions. They're going to want to ride it out. The two things we always say is run from the surge and hide from the wind. This is for those along the coast. You don't have to, if you live on, say, Cape Cod, you don't have to evacuate Cape Cod just because of wind. You're better off sheltering in place, in your home or in a safe location. However, if you live along the coast and you're in an area being threatened by storm surge, you definitely want to move to a higher ground, get away from the coastline in that case. So, again, yes, we are way, way overdue. Let's see. Another question from Jiban. I heard extratropical cyclone and sometimes super, such as Superstorm Sandy. Is there a difference? Bryce, I guess I can kind of answer this one too.
Yeah, that's kind of
Extratropical cyclone,
hard
again,
one.
is our nor'easter, our winter type system. A superstorm, that was kind of labeled almost by the media.
Yeah.
Sandy was actually a tropical system that was undergoing that transformation to a nor'easter. So it was kind of a hybrid storm, and many of ours are hybrid storms. This was certainly a higher end hybrid type storm, so it was labeled a superstorm, but that's really not a technical description or anything that we would kind of describe it. All right, good question. Question from Joe. With the warm water, would the transition to extratropical be slower? And would a storm keep more pure tropical characteristics? Absolutely.
Yeah.
And that's, sometimes what we'll see by September when our water temperatures are the warmest at that time of year. Example is Bob, example is Carol, Diane, any of those. Those were pure tropical systems as they reached us. It's just, usually they tend to be weakening as they reach us because they're not into that 80 plus degree water. But certainly, yeah, certain storms can keep those pure tropical characteristics. Good question. Question from Samuel. What does subtropical storm mean? Bryce, do you want to answer that, or would you like me to take that too?
You can go for that.
Okay. Bryce being from Tennessee is new to the tropical weather
Yeah.
community. So the subtropical is a tropical storm that has weakened below tropical storm strength, but still has some tropical characteristics. So, it can be very confusing. But so subtropical is a storm that is below tropical storm strength. It is weakened, but still has tropical characteristics. Let's see. Question. Oh, Katie has a question. Will this seminar be available to watch later? Yes. All of our webinars are on our YouTube channel. So go to the NWS Boston YouTube channel. There's a link at the bottom of our webpage. All of ours will be there. Peter has a question. What is a pre, and does a New England hurricane always generate them? And Bryce, I guess I'll take this one too.
Yeah, you go.
A pre is known as a predecessor rainfall event. So what it really means is when we have a hurricane that can, say, be over the Carolinas or Virginia, we sometimes see bands of heavy rain far displaced north from the center, sometimes up here in southern New England. And what that's essentially a result of the jet stream. The jet stream has to be in a certain position, usually running across the Great Lakes and northern New England. That actually generates some additional what's called lift. We have tropical moisture moving into the area, and we can get a band of heavy rain that can usually cause flash flooding. So we saw this with Irene. We see this with a lot of tropical systems that are off the East Coast. Whether or not they get to us directly, not always, but some of the offshore storms. I know Jose a few years ago brought a pre to the Carolinas and caused flash flooding. So that's, again, a predecessor rainfall event. It's a predecessor to the actual tropical system itself, and it's usually a band or a couple of bands of very heavy rainfall that can occur far from the center of the hurricane. So good question, good science question. Victoria has a question. In New England, the primary damage is to the west of the track. Is that the same for North Carolina? Is the damage usually west of the track? Thanks. Actually, Victoria, the highest winds and damage tend to be east of the track. So again, high winds and surge east of the track, heavy rainfall along and west of the track. So that's typically what happens. Not always, but about, I'd say, 90% of the time. That's what we have here in New England. Good question. Catherine, what factors are predicted to be in place for an active hurricane season this year, and how are those factors likely known now? Well, it's actually done kind of on a very large global scale, not unlike our winter weather outlooks that we see. Things like El Nino are taken into account. That has to do with the amount of wind shear over the Atlantic, whether it's an El Nino year, a La Nina year, you may be familiar with that. Things like basic sea surface temperature predictions. There's a lot of what are called global factors that go into these outlooks, and not really very localized. So it's a general outlook for the entire Atlantic Ocean. And those are a couple of the factors they were looking at this year. As far as landfall, no one knows. Those things aren't really known until the storm forms, and at best, maybe 7 to 10 days out, we can see the pattern that may be in place. But that can change, almost up to a few days ahead of the storm. So typically, again, it's global factors that go into those outlooks. Katie said, let's see, the storm surge graphic is weird. Consider all other graphics go watch then warning. Oh, that's just, yeah, you're right. That's
Yeah, it was placed on the left versus right.
You are correct.
It
Katie,
is.
you're being very observant. Thank you. We will actually, they're going to have to, that was a graphic we were given by the Hurricane Center, so we will run that by them and tell them to please fix it. Thank you. Let's see. Kevin says, already answered a question, but what are the thoughts about the 2020 season in comparison to 2005? I believe we're in an active, Bryce, you may remember off the top of my head, I know we're going for a more active season, not
Yes, I do know that.
record-setting season, but definitely a
Yeah,
more active season.
I think they said that like the sea surface temperatures are extra warm or really warm or is one of the factors, but they are predicting a more active than normal season.
Right. Okay, good. Question from Fred. At this point in time, are the water temperatures favorable for tropical development this season? I would say yes, and that kind of is what helped Faye get developed off the Carolina coast. Temperatures are a little bit above average there, and they're starting to warm here as well. Not obviously quite as warm yet. Our peak water temperatures are in later August, September, but at this point, yeah, the temperatures in the Atlantic Basin are running fairly warm, so that again is a favorable factor. One of the factors that goes into the forecast of an above average season. So good question, Fred. Question from John. What is the difference between a post-tropical cyclone and an extratropical cyclone? Oh, good. See, this is the problem. We have too much terminology.
I know.
But there is a difference. So a post-tropical cyclone, it's similar. They're both similar things, an extratropical. So really what they're doing is now no longer using the term extratropical in the advisories. So say we have a hurricane or a tropical storm coming up the coast, and it's turning what I call extratropical, turning into the nor'easter type storm. The National Hurricane Center, in coordination with us and the other offices, will not call it, say, well, tropical storm Bryce has gone extratropical. It'll say it's a post-tropical cyclone, meaning it's after its tropical characteristics. So really the same thing. We've just changed the terminology because in some cases, when we said extratropical cyclone, people got actually very worried and said, well, meaning extra, like beyond tropical. So now it's gone to something even worse. Yeah.
Yeah.
So they've changed the terminology just to post-tropical cyclone. So I know it's confusing. It's even confusing for us. So good question. Colin has a question. What are some of the major factors that contributes to a tropical cyclone's track? Bryce, you want one?
Yeah, sure. So
right.
the biggest factor is the locations of high pressures and low pressures elsewhere, up towards the subtropics. So these areas of high and low pressure will basically help to steer the storm or block the storm from heading straight north or push it out to sea. So the biggest factor is the high pressure blocking and other areas of low pressure that would interfere with where it wants to go. So it kind of gets pushed around by other areas of high and low pressure. That's really the main thing. Joe, what am I missing? Is there
that's correct. So the thing I've always heard was when there's a hurricane, say in the Caribbean or in the tropical Atlantic, it's almost like having a blob of Jello in a bathtub. It's going to go where it wants to go. There's nothing to really necessarily steer it. Usually, the steering currents in the tropics are relatively weak. When it gets up into our latitude, especially north of the Carolinas, now it's coming into the influence of what are called the westerlies, the jet stream. So depending on the pattern of the jet stream, is it due west to east? That's going to push the system offshore. Is there a big dip, a big trough in the jet stream, like when we get our big winter storms that will help it ride up the coast? That's kind of what we start to look at as we get up to our latitude here. But in the tropics, typically it's just going on the very relatively weak steering currents going from east to west. Or if there's some sort of high pressure kind of steering it, you'll see that a lot of times. So good question. All right, question from Michael. Can the hurricane of 1930 happen again? Has any hurricane taken a similar track? Michael, yes and yes. Um, like we said, we're overdue for a major hurricane, and certainly that can happen again. Hurricanes have taken similar tracks. The hurricane of '38 went northward through Connecticut. Several of the hurricanes in the '50s took a similar track. Some have taken tracks across Long Island and the Connecticut. So yeah, it just again depends on what our jet stream pattern is like at the time, as to where the storm eventually tracks. Let's see. What was Sandy technically characterized at landfall from Brian? I believe it was a post-tropical cyclone at landfall, with tropical being tropical just prior to that. And I know there was a lot of debate, and there still is a lot of debate over whether it was or not. Um, I defer that to the experts at the National Hurricane Center, who are well versed in all things tropical. And I believe at that point, based upon the observations from the aircraft and land and balloons, actually too, it was technically post-tropical, but the impacts certainly were that of a hurricane, no question about that. Tom, let's see. Do you recommend any specific weather radio for storm preparations? Handheld scanner? Really, Tom, any kind of weather radio that has a battery backup is preferred. Again, if you should lose power, having that battery backup is very important. So really, any kind of weather radio that has battery backup capability is highly recommended. Frank has a question. How current are the MEMA inundation maps to reflect rising seas? I believe they are current within the past few years and are in the process of being updated. So I would have pretty high confidence in them. We use similar inundation maps for our coastal flood program, and I can tell you the LIDAR data that went into them from aircraft is only a few years old, so that it is fairly accurate. So, and they are working. I know they're being continually updated every few years. I'm going to hand this next one to Bryce to give my voice a rest. From Eric, why are hurricanes more prevalent later in the season?
Well, basically, the later in the season, the heat and humidity is it's just increasing through August. The water's getting warmer, and that's basically the fuel of the storm like we talked about. That there's more of that over 80-degree water to provide the fuel. So it's just a function of the later in the summer, the hotter the water gets, and the more that there is for the hurricanes to run off of.
All right, there you go. Question from Kathleen, and folks, we're going to answer all the questions we have a few more, but we're going to keep going, so feel free to stick with us. From Kathleen, why was the no-name storm in 1991 not named? That's because that was a hybrid storm. That actually was a nor'easter that actually had energy kind of infused from a tropical system. So again, it was one of these hybrid storms, not purely tropical. So in those situations, it's typically not going to get a name, but obviously the impacts of that storm were tremendous, not just at sea, but also on the southern New England coast. So typically it has to be a tropical system for it to get a name. In that case, it was late October, Halloween, and it was actually what we call the cold core system, the nor'easter type system, but had energy infused almost from a tropical system. And similar question from Stephen. What is the process of a tropical cyclone transitioning to a cold core system? Can a system be considered mild core? No, it's typically one or the other. So again, as the tropical cyclone, the warm core system is moving north and interacts with the jet stream. It loses, if it loses that source of warm water, that's its engine. That's what its fuel. If it loses that warm water for its source, it's going to come more under the influence of the jet stream, and that in turn sets up a whole bunch of processes, which I won't even get into, but turns it into what we would call maybe a nor'easter or a typical coastal storm, so which is a cold core system. So it undergoes that transformation, again, due to the jet stream, but because of that loss of its heat engine, which is its warm water source.
I like that name though, mild core.
Mild core.
We don't need any more names though.
Yeah. Another question from Jiban. How can I download hurricane data from my research? I get lost in the NOAA website. So do I. The best place to go, I would say, would be the National Centers for Environmental Prediction. Google, or search, I shouldn't say Google, NCEI, capital letters, and you will get to that. They have a pretty easy way of downloading hurricane data. So if you need additional help, you can email me. You have my email address, I think, on your webinar confirmation, and I can certainly help you more with that. A question from John: higher the water temperature, the stronger the storm. Bryce, you want that one?
I want to say that is true. That the hotter that the temperatures are, the more strength the storm can get. But I also am not 100% unsure. That's true,
Yeah,
right?
I would say potentially, yes. Not always, but yeah, if you have a
Yeah,
warmer
that
water.
more
So
potential.
in other words, when you've got a storm going into the Gulf of Mexico in August, September, it's like bath water there. Those storms
Hmm.
strengthen very rapidly. Can they get to category 4 or 5? Absolutely. Do they always? No. I mean, that's just one part of the equation. But
Yeah.
yes, that certainly puts the odds in the favor for a stronger storm. So good job, Bryce. You got that pretty much.
Oh yes.
Question from Brian: what altitude do the hurricane hunters fly at to determine speed?
Oh
Bryce,
gosh.
I
I
well, I know that we have two types. So we have the Gulfstream aircraft, which is the kind of the private jet in the NOAA fleet that flies well above the storm at jet stream level to sample above. The hurricane hunters fly, I believe, somewhere around 10,000 feet, depending on the actual storm itself. They obviously don't go too low for their own safety. I believe they're between 10 and 15,000 feet for the most part. I would have to look that up to be specific, but kind of in that general area is where they go through the storm at different cuts through the storm. Yeah.
and they were actually here last summer at the Hurricane Awareness Tour. Some of you, I don't know if you may have come to Rhode Island to see them, but they actually brought the planes down here, and we got to take tours of them. So that was pretty neat.
Yep. That's right. And hopefully, well, uh, you know, COVID things aside, we'll be on the East Coast
Hmm.
again next year.
Yeah.
From Katie, a comment: again. We talked about the predecessor rainfall event. Sort of took place in Gloria, and with Tropical Storm Henri. Was that a rare event, where if two tropical systems made landfall so quickly before? No, that's not unusual. We see pre's with a lot of tropical systems that come north into the area, and to make landfall quickly. No, that's pretty typical. Those systems were pretty typical for landfalling systems in New England. So yeah, good observation and good memory. Question from Paul: was there an event that got you interested in meteorology? We can answer this quickly. For me, there were a few. I grew up in the New York City area, so I had the blizzard of '78 down there, not up here, which wasn't quite as bad, but it still dumped 2 feet of snow. I like that one. Also, Hurricane Gloria. I lived through that down in New York, and I remember seeing actually part of the eye, experiencing part of that. Those were two events that kind of stand out for me. Bryce?
Yeah, myself, there's not really one that stands out particularly. There was a tornado that came near our house where I remember having to get under the stairs, and that was one of my first memories of being fascinated slash scared of the weather. I don't really have a actual one event that got me into it. I do remember that the movie Twister came out in I think '96 when I was 6 years old, and that made me actually realize you could do that for a job, and that really kind of spurred me into it. So a fake event kind of got me more into it.
That still counts. All right, just a couple more questions here. One from Fawn: has the city of Boston ever had an evacuation order due to a hurricane? What is the likelihood that the city of Boston or any suburbs would need to be evacuated? I would say low. First of all, no. I don't. As far as I can recall, Boston has not had. It's the city itself has not had an evacuation order due to a hurricane. The likelihood for the suburbs is probably slim to none. Again, we talk about hide from the wind and run from the surge. So, in the case of Boston, the areas that will be vulnerable to storm surge, would be evacuated or recommended. I don't believe they can mandate it, but would be under, strong advice to evacuate areas that could be prone to storm surge flooding. That would be about it. Typically not from the wind, though. So we would have to have a storm. If we took Sandy, that took landfall in New Jersey, and say Sandy actually made landfall somewhere maybe near Montauk, Long Island, or southern Rhode Island, that actually would cause a similar surge that New York City got into Boston, believe it or not. And in fact, the year before we had Sandy, we actually worked with the city of Boston Emergency Management and ran an exercise just for that exact scenario. We had a landfalling hurricane moving due west across Long Island and into Rhode Island that brought massive storm surge into Boston. So, a coincidence? Yeah. But if Sandy had actually shifted a little bit farther north, the flooding that you saw that occurred in New York City would have impacted Boston. So that's a little interesting fact you can spread at the dinner table tonight. But yeah, Boston, I would assume, would have some sort of evacuations for storm surge, but not for wind. Let's see, question from Jimmy. How does Sahara dust interact with Atlantic hurricanes? It actually is not a good thing for Atlantic hurricanes. The dust can kind of interfere with the circulation and with the convection, those bands, those rain bands, and cause a lack of development. So you'll actually see sometimes the Sahara dust on the satellite image. That's actually not conducive for tropical cyclone formation. So good question. Josh has a question. Which part of the hurricane is used to define landfall? That would be the eye, actually, itself. So they would have observations typically based on radar that's used to define where the storm made landfall. In the case of Faye, it was the radar down at Fort Dixon, New Jersey, near Philadelphia, that was used. So typically it's the coastal radar that is used. Let's see. We got a few more questions. I've got a few. Let's see. John has a question. Why does a secondary peak of tropical system formation occur in October? I can take that, I guess.
Yeah, go for it.
Typically, the sea surface temperatures are still relatively warm at that point. So there can be, and if the conditions are just right, you can get a tropical system to form usually in the Caribbean or somewhere in the southern part of the Atlantic, and occasionally those storms will make it farther north. But still, it's just due because you still have warmer sea surface temperatures at that point. Question for Colin: what is the typical altitude of a hurricane? I guess he means the top part. Bryce, you want to grab that one if you know offhand?
That escapes me actually. Do you know?
Yeah, I mean the top of the storm. It depends on what you said, like the tropopause and tops of thunderstorms. Depends on the storm. Typically it can be anywhere maybe 40 to 50,000 feet in some of the higher tops around the eye. Just depends really on the strength of the storm. So I'd say anywhere maybe 30 to 50,000 feet. Just depends. That varies. Let's see. Let's go through a few more, and we'll keep going. So feel free to hang with us. Question from Larry: do you expect global warming will change hurricane paths in the future? Doesn't have much to do necessarily with the path. Certainly, warmer sea surface temperatures are more of an energy source for our hurricanes. It can have some impact. Warmer sea surface temperature also can have more impact on the jet stream. Can be more what we call a blocky pattern. So maybe I would say, but as a meteorologist, I don't deal too much in the climatology aspects of climate change and things like that. It's kind of unknown at this point. The jury is kind of out, but certainly the potential is there, maybe not for more hurricanes, but for hurricanes that can strengthen more rapidly and for stronger hurricanes. Not necessarily ones that make landfall, but if you have more stronger hurricanes, then certainly if they do make landfall, then there's potential for more damage. So good question, and kind of one that the jury's out on. Question from Peter: do you think the hybrid Christmas nor'easter of 1994 might be included in the HURRDAT reanalysis? That's the hurricane reanalysis. Probably not. That was a hybrid system, a little known system too, but it's actually in our weather history series on social media, so that'll be tweeted out around Christmas time. That was again a hybrid. It was a typical winter storm, kind of with some almost tropical injection, believe it or not, even though it was in Christmas. I don't think, Peter, that one will be, just because it wasn't a true tropical system. But good question. Another question from Joe: if a hurricane hit southern New England this year, what would the forecast office operation be like during the pandemic? I guess that one falls on me since I'm one of the managers.
Yeah,
so typically, just so everybody knows, we are maintaining our operations throughout this whole pandemic. We limit the number of people in the office, but we do keep enough to maintain operations. So, typically our shifts are 3 people on the day shift, 2 people at night. When we have weather like these thunderstorms, we staff up as needed. So it will be all hands on deck, Joe. We're able to, our workstations are far enough apart. We're able to maintain social distancing safely. So we have actually 8 workstations. Those will be maxed out. I can tell you that right now. We typically, in a tropical situation, have a day shift and a night shift. We work 12 hours on, 12 hours off. And anywhere, I would say, between about 6 and 8 people per shift, probably closer to the 8. would be on shift at one time, but we would be able to manage and do our normal operations despite the pandemic. So good question, Joe. I'm sure a lot of people aren't really too familiar with that. From Danielle, are thinking making adjustments to the Saffir-Simpson scale since people may not take Category 1 as seriously, like flooding from Florence? And yes, they are, Danielle. In addition to wind, I believe there are researchers looking at the storm surge aspect of it. So in the coming years, we may see some adjustments to that. Let's see. And from Katie, okay, Katie's giving me some info on the no-name storm. So November 1st, the system evolved into a full-fledged hurricane with peak sustained winds of 75 miles an hour, although the National Hurricane Center left it unnamed to avoid confusion amid media interest in the precursor extratropical storm. And that's probably true because once in those kinds of situations where it could go either way, once they start it as a non-tropical system, they tend to keep it that way. And that's something we often discuss with the Hurricane Center days before a system, like with Faye. A few days before, we have a conference with the National Hurricane Center folks, and how are we going to handle this? And in this case, with Faye, it was definitely a tropical system, so we went the tropical route. But in that case, yeah, it was. I believe they made the decision not to go that route. So even though it did acquire tropical characteristics, they kept it the same. So these days, I would hedge the bet they would go the tropical route with that kind of system. So, Katie, thank you for the research. So, good questions. Okay, and with that ends our questions. We had a pretty long webinar tonight, but I hope everybody enjoyed it. We are, again, this is recorded. This will be posted to YouTube, I guess, tonight, Bryce, or tomorrow?
Tomorrow when I get in tomorrow.
Yeah. So we'll give Bryce till tomorrow to post it. So, again, all of our webinars are there on the YouTube page. If you have any questions or comments, please send them to me. My email address is on your webinar confirmation. I've been getting a lot of nice feedback from folks attending, some good ideas for future webinars too. And the most popular question I will say is, where can I find the recording? So it's the YouTube channel for NWS Boston. So there you go. So again, thank you so much for joining. We had a really good turnout tonight, probably one of our highest turnouts. So again, let's play it safe for this tropical season. Please go to that webpage or link to our webpage for your hurricane safety plan. Please have one for you and your family. It's not just for those on the coast, but for those inland. And we certainly will be keeping an eye on the tropics over the next few months, and we'll keep everybody informed. So the one thing we will do, I will mention, when we get into maybe a significant, if we do get into maybe a landfalling hurricane or tropical storm, we will go live on our NOAA Weather Radio and actually do live broadcasts. So that's something we reserve for kind of our more significant weather events, hurricanes, tropical storms, maybe a very high-end severe weather day, or even a high-end blizzard. We're going to start doing that a little bit more too, have some live broadcasts. I think even Bryce Facebook Live we're going to be getting into as well in the future. So look for Facebook Live, look for NOAA Weather Radio Live for those of you with weather radios, and I hope that's a lot of you. So we're going to be expanding, and Bryce can tell you this too, our social media presence a little bit more with doing these kind of live, not just webinars, but live briefings on Facebook during severe weather events or high-end weather events. So look for those. And again, I thank you all for joining. Enjoy the rest of your evening, and look forward to the heat and humidity this weekend, I guess. So.